did another variable which was, you're right. That was just an example, I wasn't, yes, you're right. But I chose to do a different one, just to illustrate. I thought this was a better one to illustrate this one, so you're absolutely right. We did that, that's fine. So it makes no difference, it's the interpretation that matters. Okay. So I did it for this one, because I thought it was the best. I just used the data, I've given the example 113, but I did a different analysis. So here I was predicting the level rate of graduation after 4 years and use different variables. So I will give you something like this and ask you the question, is this a good regression or not, for example? So what are we going to look at to determine whether it is a good regression? The first number, we look at the adjusted R squared. Multiple regression, so the adjusted R squared is the one that matters. If I give you a simple regression, it will be the R squared that matters. Is this a good adjusted R squared?
No.
Okay.
So, the adjusted R squared, remember, is called the coefficient of determination, which means how much of the change in the dependent variable is explained by the independent variables. And in this case, these three variables I chose explain 41% of the changes in the dependent variable, which means that there's 59% or 58.5% that's explained by other factors. So it's not a particularly good one. Then,
how would you say, like, is it 40% is good, about 40 is about 50?
yeah.
What's the good, what's bad?
Normally, the very good is above 80. Somewhere above 70 it is good. Somewhere between 40 to 60 it is okay. Anything below 40 doesn't explain much. There are a lot of other variables that explain more.
So like example
When it's multiple, yeah. The difference between the R squared and the adjusted R squared is an adjustment for the fact that there are more than one variable. Then we look at the coefficients. And in the coefficients, we can look at it in one of three ways. Either look at the t-stat, and we want it to be very high, so that it is in the rejection area, because what we are testing is whether the coefficients are equal to 0 or not. If they are equal to 0, they are not significant. We cannot predict the dependent variable on the basis of their independent. We look at the p-value, and we want it to be as close to 0 as possible. Or we look at the confidence intervals, and we want it not to include 0. So in this case, if we look at the first variable,
Carlos, can you just say a t-stat thing again?
t-stat, we want it to be as high as possible. We are normally comparing to a t-critical around 2. We've seen the t-critical here, 196 for the 95% confidence interval. We saw 1.984. T-critical is around 2. So if we have a t-value above 2, it will be in the rejection area, which is what we want. We want to reject that the coefficient is equal to 0.
Excuse me, do you need to use all three?
No.
Or just
I
one?
one of them. Yeah. It's that. Yeah. 23 is good. That means we can reject that the intercept is equal to 0. But the intercept is the one that matters the least. What matters is the other coefficients. Or confidence interval. You just need one of them, not all three of them. So this clearly says that this variable, this coefficient is significantly different from 0. That as well, they are very far from 0, a lot more than 2 or minus 2, but this one is not. So that's
So it's not about
115.
being high, it's just being away from 0, minus 4.
It's high in absolute value, more than 2. So either more than 2 or less than minus 2. Yeah. You want it to be away, yes.
So further away, so if it's larger than 2,
then
you
in
reject.
principle the coefficient is significantly different from 0.
So, but you reject the null hypothesis.
We reject the null hypothesis, which is what we want to do. If we accept the null hypothesis, for example, if we are predicting sales based on the number of customers walking through the door, if the coefficient is equal to 0, it means that if we get more customers through the door, our sales can go up or can go down. But if it is significantly different from 0, if it is positive, we know that the more customers we have walk through the door, the more sales we have. So when we do our advertising, we may say, if we make sure we get lots of customers, we'll increase our sales. So that's what we want to do. P-value, we want it to be as close to 0 as possible. That's the significance level. So as long as it is less than 0.05, then we can accept with 95% confidence that it is different from 0. And probably the easiest, I would suggest, is to look at the confidence interval. This is between minus and minus. Does it include 0? It does not. Between minus and minus, does it include 0? Does not. This is between minus and plus. Does it include 0?
Yes.
It does. So we cannot be confident that this student-faculty ratio actually has an effect on the percentage of students graduating after 4 years. So it can be positive or it can be negative. With 95% confidence, we do not know. Okay? So what's the logical next step? Do it again, taking this variable out. So we can see here the adjusted R squared is 4143. If we go and take that out, we now have both coefficients being significantly different from 0, and our adjusted R squared went from 4143 to 4128. So did we lose anything? Pretty much the same. So this is a much better model. I now have a model that allows me to predict graduation rates after 4 years based on these two variables. But, as we said before, that's not very impressive, 41%, so we try others. And so I tried another one, and is this one better?
Yep.
Yes.
Much better, 58.3, so this is a better model. But this model has a problem. If we look at the coefficients, 2 of them are non-significant. Okay, so what I did next, take one out first, and did the adjusted R squared change?
No.
Not significantly, I think it actually went up a little bit. So that's 5834, that's 5874, so I took a variable out and it's even a better model. But I still have one variable that is not, one independent variable that is not significantly different from 0. So, looking at all of these, what would I be asking? Questions along the lines of which one is the better model, why is it a better model, how much can be explained, and then I can ask questions along the lines of how would you suggest we change the model, so introduce other variables or anything that you think would be applicable.
If you have multiple variables that are not significantly different from 0 in one model versus, just having one that's not significantly, but it's you have a lower adjusted R squared, which one do you?
Well, you try various. You try, if that's the case, if you're doing it, you try various combinations. You take one, you take another one, etc. And then you take 2, if you got 3 or 4, depending on how you start. If you start with, say, 10, then you take one at a time. And then you put back, and then you see which one's the best.
For example, like when we get to this one's at 57, the other 41, that gig is significant enough that you'd rather have 2 variables that are not significant than the one that gives you.
No. In this case, I would rather, if the difference is small, I would rather have a model with less non-significant variables always.
And okay.
So out of these, which one would you recommend?
So out of this one, the best model is the regression 4, because the adjusted R squared is high,
Yeah.
and even though I have 1, I would, I still have one, but it's the better model. What I would suggest, for example, if I was to ask the question, how would you improve? The improvement would be take this total cost variable and try to use another one and see if I can have an adjusted R squared at the same level with no non-significant variables. Okay? So I think our time is up. There's probably somebody at the door already. So if you have any questions, by the way, yes, just a second.
Sorry, I came a couple of minutes late. The exam, the past exam papers,
I'll put it on.
they're almost, yeah, the ones that I looked at two yesterday, 2017, they're almost identical.
Yes.
Is it going to follow a similar format?
I put a file that I went through at the beginning, and you can see on movement. Okay. So what I was going to say, if you have any questions, just email me. That's fine, not a problem. And